Is the vacuum truly empty? I invite you to join me on an intellectual journey that will challenge everything we think we know about reality. A journey that questions our intuition and shakes the very foundations of our understanding of the universe, because if there is one thing we have learned as observers of the quantum world, it is that the cosmos is a master of illusion. And its most astonishing trick, one capable of transforming our view of existence itself, hides precisely where we least expect it, in what appears to be nothingness. From an early age, we are taught to believe that the space between stars, the inside of a container, or even the heart of an atom is simply empty. Regions without content, lifeless gaps, passive stages waiting to be filled. But what if that idea were one of the greatest misconceptions ever conceived? What if what we call the vacuum were, in fact, a vibrant ocean, an invisible cauldron of energy, an active fabric pulsing with the essence of existence itself? Imagine a space that seems silent and dark, devoid of particles, light, or matter. A place that appears to contain absolutely nothing, yet conceals one of the most fundamental and mysterious forces in the universe. Classical physics, the physics of Newton, gears, and predictable motion, taught us to see the cosmos as an orderly machine, where every cause has a clear effect and the vacuum is merely an inert backdrop for the cosmic drama. But that picture began to collapse with the arrival of quantum mechanics. This new way of understanding reality, born from the study of the infinitely small, revealed a universe that is strange and unpredictable. A universe where particles can exist in multiple states at once, where the act of observation alters what is observed, and where the vacuum, far from being inactive, is a stage of constant activity. Think of the atom. For a long time, we imagined it as a dense nucleus surrounded by electrons, separated by vast empty spaces. Yet quantum reality is far more fascinating. Those spaces are not devoid of content. They are saturated with what physicists call quantum fluctuations. Even in the most remote regions of interstellar space, where there are no stars, no atoms, not even dust, energy never stands still. It appears and disappears in a perpetual flow of fleeting particles that emerge from nothing and return to it in an instant, like flashes in an invisible sea. This phenomenon is known as the quantum vacuum, one of the most revolutionary and yet least understood concepts in modern science. It is not an absolute absence, but a state of minimum energy, a delicate balance where, due to the fundamental uncertainty of quantum mechanics, particles are constantly created and annihilated. Although these entities cannot be observed directly, their effects are measurable and real. If we could observe the vacuum at extremely small scales, we would not find silence, but a constant hum, a quantum fog where pairs of particles and antiparticles briefly emerge, travel infinitesimal distances and annihilate one another, returning their energy to the field from which they arose. An eternal flicker, an invisible heartbeat that never fades. This constant dynamism is what gives the vacuum its immense, though hidden, energy. Understanding the true nature of the vacuum goes far beyond scientific curiosity. If the vacuum is not absence, but pure potential, what does this mean for our understanding of the universe? If what we perceive as nothingness is actually a vast reservoir of energy, could it be the source from which everything arises? This idea, both poetic and scientifically grounded, invites us to reconsider not only the cosmos, but also our place within it. It suggests that we are part of a deeply interconnected system where even the space between ourselves and between our thoughts is permeated by this same fundamental energy. The question now before us, the one that will guide the next steps of this journey, is how this dynamic vacuum interacts with the matter we know. Could it be the origin of the particles that form galaxies, stars, planets, and life itself? Is it the true cosmic womb from which all existence emerges? Answering these questions does more than expand scientific knowledge. It transforms the way we understand reality and ourselves. We have begun to glimpse the true face of the vacuum, not a face of absence, but of infinite possibility, a face that hides the deepest secrets of creation. But how do we know this is true? Is there tangible proof that nothingness is filled with activity? To answer this, we must explore one of the strangest and most beautiful phenomena in quantum physics, a direct demonstration that the vacuum can exert force. Let us turn to the Casimir effect. Imagine an apparently empty space. Now place within it two parallel metal plates, extremely close to one another. Intuitively, we would expect nothing to happen. There is no air, no visible particles, no obvious forces at play. Yet in 1948, physicist Hendrik Casimir predicted something extraordinary. Even in a perfect vacuum, these plates would attract each other. How can nothing generate a force? The answer lies in the quantum nature of the vacuum. This space is not at rest. It is filled with energy fluctuations of every possible wavelength. When the plates are introduced, they act as boundaries, restricting which waves can exist between them. Only certain quantum notes can resonate within that confined space. Outside the plates, all wavelengths are allowed. Inside, only a limited set can exist. This difference creates a slightly greater pressure on the outer sides than on the inner ones, gently pushing the plates toward each other. The force is tiny, but it is real. A direct, measurable proof that the vacuum is not empty, but a dynamic ocean of invisible energy. Like two boats floating on a turbulent sea, the waves outside are larger and more numerous, inevitably pushing them together. The Casimir effect stands as one of the most striking confirmations of the inherent activity of the quantum vacuum, a clear demonstration that even what seems like nothingness harbors powerful, measurable phenomena. The first experimental verification of this prediction did not occur until 1958, when Marcus Spanier conducted preliminary measurements, albeit with significant margins of error. It was not until 1997, with the meticulous experiments of Steve Lamarose, that the Casimir effect was measured with remarkable precision, aligning almost perfectly with Casimir's theoretical predictions. This achievement marked a turning point in physics, providing undeniable evidence of the vacuum's vibrant, active nature. This discovery extends far beyond a mere laboratory curiosity. It compels us to rethink the very foundation of reality. If the vacuum can generate a tangible force, it is not simply empty space. It is a physical entity with intrinsic properties and an extraordinary capacity to influence the universe. It reveals that what we often consider nothing is in fact a reservoir of potential, a latent energy that underlies everything we observe. Consider the implications. If the vacuum can give rise to such subtle forces, what other phenomena might emerge from its depths? If the fabric of space-time itself, even in its most seemingly inert state, is teeming with creation and annihilation of virtual particles, might the vacuum be the true engine of the cosmos, the beating heart of existence itself? The Casimir effect not only confirms the presence of virtual particles, but elevates the vacuum from a passive backdrop to a central player in the cosmic drama. It illustrates that reality is not static, but a continuous, dynamic flow, a manifestation of the underlying energy that fuels everything. The vacuum is not a passive recipient, but an active creator, a place where the laws of physics materialize into observable effects. It is a subtle yet powerful dance that urges us to look beyond appearances, to understand that reality is far deeper, more mysterious, and more astonishing than our senses suggest. The Casimir effect offers a window into this hidden realm, a reminder that even where absence seems complete, presence is undeniable. Virtual particles, the unseen architects of this subtle force, are ephemeral entities that emerge and vanish instantaneously, forming the most fundamental expression of vacuum energy. prepare to enter a domain where reality blurs and what appears to be nothing becomes an unceasing incubator of creativity. At quantum scales, the universe is anything but stable or predictable. Governed by Heisenberg's uncertainty principle, subatomic reality is a dynamic, playful arena where certain properties of a particle, such as position and momentum or energy and the time it exists, cannot be known simultaneously with precision. What does this mean for the vacuum? For incredibly brief moments, it can borrow energy to spontaneously create particle-antiparticle pairs. Imagine the universe as a cosmic bank. Although money cannot be created permanently out of nothing, short-term loans can occur. In this case, an electron and its antiparticle, a positron, may spontaneously emerge from the vacuum, exist for a nearly imperceptible instant, and then annihilate each other, returning the borrowed energy. These fleeting particles, invisible to current instruments and therefore called virtual, are more than theoretical abstractions. Their effects are real and measurable. The Casimir effect demonstrates their existence directly. These continuous cycles of creation and annihilation generate the asymmetric pressure that draws the plates together, much like bubbles in a pressure cooker generating a measurable force. But virtual particles do more than produce a force. They are fundamental to the stability and interactions of the entire universe. They influence the effective charge of electrons, create fleeting clouds of polarization, and shape how matter interacts, subtly but critically. Without them, our understanding of fundamental forces, like electromagnetism, would be incomplete. Think of virtual particles as the silent workers of the cosmic factory. Though unseen, they constantly mediate interactions, contribute to the properties of matter and energy, and ensure that the laws of physics operate as expected. They are the invisible pulse of the cosmos, a reminder that even apparent stillness conceals frenetic activity shaping reality. Each virtual particle's life is unimaginably brief, appearing from nothing, traveling infinitesimal distances, and dissolving back into nothing in the blink of a quantum eye. But their impact is monumental. Their ephemeral existence reveals the vacuum not as passive, but as a living, dynamic environment where creation is constant. These tiny, omnipresent particles hint at a profound truth. The vacuum is not emptiness, but the engine of existence, the vibrant core of a universe far more complex and astonishing than we have ever imagined. From this perspective, the quantum vacuum may be more than a backdrop. It could be the true origin of everything, the cosmic womb from which all matter and energy emerged. The question that naturally follows is bold. How did the universe arise from this vacuum? For decades, the Big Bang theory has offered the most widely accepted explanation, describing the expansion from a hot, dense singularity 13.8 billion years ago. Yet it leaves us with an enduring question. What existed before the Big Bang? Where did that initial singularity come from? Here, the quantum vacuum steps in spectacularly, offering a scientifically plausible explanation. That the universe itself could have sprung from this seething, energetic nothingness. Not mystical, but deeply rooted in the fundamental fabric of reality. If the vacuum is an ocean of fluctuating energy, a realm where particles constantly appear and vanish, it is not unreasonable to imagine that one of these fluctuations might have been so immense and powerful that it triggered the creation of the universe as we know it. Picture the vacuum as a fundamental state of minimal energy. In this state, quantum uncertainty is unavoidable. Absolute, static nothingness cannot exist. There is always a subtle hum, a constant bubbling of energy that manifests in the creation and annihilation of virtual particle pairs. Yet, in a fleeting instant, one of these fluctuations could generate enough energy, a brief loan from the cosmic bank, to set off an expansion. This is the essence of what some physicists describe as the spontaneous creation of the cosmos from the vacuum. We are not speaking of nothing in the philosophical sense of total absence, but of quantum nothingness, a state devoid of visible matter, yet saturated with latent energy and potential. It is as if the universe were a bubble forming in the foam of this quantum ocean, a fluctuation so intense that it did not collapse, but expanded rapidly, carrying with it all the energy and matter that make up our cosmos. The theory of cosmic inflation, a modern extension of the Big Bang model, supports this view. It proposes that during the universe's first moments, it experienced a period of incredibly rapid expansion, driven by the energy of a scalar field, a type of energy potentially linked to the quantum vacuum itself. In this sense, the vacuum is not a passive backdrop, but an active engine of infinite potential. Within it, all possible configurations and all possible realities coexist as potentialities. Our universe, with its specific physical laws, galaxies and stars, would be just one of countless configurations that could arise from this vast sea of potential. This leads naturally to the fascinating concept of the multiverse. Our universe as merely one bubble among many, all emerging from the same fundamental quantum ocean. If the cosmos is essentially a temporary loan of energy from the vacuum, what does this imply for our own existence? It suggests that we are not mere products of a random explosion, but manifestations of a potential inherent in the fabric of reality. Every atom in our bodies, every star in the sky, every thought in our minds, traces its origin to the invisible fluctuations of this energy ocean. The vacuum thus becomes not only the origin of everything, but the perpetual source from which matter and energy continue to flow even today. This vision, poetic yet scientifically grounded, inspires both humility and awe. It reveals that apparent nothingness is, in fact, the cradle of cosmic complexity. It is not just where we come from, it is the source from which novelty continuously emerges, the silent engine of existence. Life and matter are not anomalies. They are natural expressions of the infinite possibilities residing at the heart of the quantum vacuum. We have seen how the vacuum, far from inert, is an infinite reservoir of energy capable of generating all that we know. The next chapter of our journey takes us to one of the universe's most mysterious forces, dark energy. This invisible force, a kind of ghostly pressure accelerating the expansion of the cosmos, might be a direct manifestation of the energy inherent in the quantum vacuum itself. For decades, scientists assumed that the universe's expansion would slow down due to the gravitational pull of all matter. Yet in the late 1990s, observations of distant supernovae revealed something astonishing. The universe is not only expanding, it is accelerating. Imagine a car that, instead of slowing when you release the accelerator, speeds up on its own. This surprising reality was called dark energy, constituting roughly 70% of the universe's total energy density. Here is where the connection to the quantum vacuum becomes truly intriguing. One leading hypothesis is that dark energy is nothing less than the energy of the vacuum itself, the effect of the ceaseless creation and annihilation of virtual particles, generating an intrinsic pressure that pushes galaxies apart faster and faster. This energy does not dilute as space expands. On the contrary, it remains constant per unit volume. As the universe stretches, more vacuum emerges, maintaining the density of this energy. Unlike matter or radiation, whose density decreases as the universe grows, vacuum energy exerts negative pressure. Instead of pulling, it pushes, like an intrinsic anti-gravity. This ghostly pressure arising from the quantum depths of the vacuum could be the engine driving the accelerated expansion we observe today. Yet the challenge is immense. Theoretical calculations predict a vacuum energy density billions of times greater than what we actually measure, a conundrum known as the cosmological constant problem. Nevertheless, the link between the quantum vacuum and dark energy remains one of the most promising pathways to understanding the universe's future. If dark energy truly is vacuum energy, then the fate of the cosmos is fundamentally tied to the nature of nothingness itself. It implies that the universe will never stop expanding. In fact, it will accelerate ever more until galaxies drift so far apart that the cosmos becomes cold, dark, and empty, a scenario called the Big Freeze. And even in that distant future, in the stillness of a vast frozen universe, the quantum vacuum will continue to exist, bubbling eternally with its fleeting, unceasing energy, dark energy, an eternal force. Driving the universe. Dark energy, as an eternal and omnipresent presence, will continue to drive the expansion of the cosmos. It is a powerful reminder that nothing is ever truly empty. This force transcends ordinary matter and radiation. It is a fundamental manifestation of the inherent potential embedded in space-time itself. Dark energy is not just an abstract concept, it is a window into the very nature of reality, showing us that the universe's deepest mysteries are often hidden in the most unexpected places. It forces us to consider that the vacuum of space is not only the origin of creation, but also the architect of the cosmic destiny. We have explored how the quantum vacuum is a vibrant sea of energy, potentially the birthplace of our universe, and the invisible engine behind its expansion. Now let's turn our attention to some of the most enigmatic and extreme objects in the cosmos, those that challenge our understanding of space and time. Black hole. Could these cosmic singularities be more than mere gravitational sinks? There may be a profound connection between black holes and the nature of the vacuum, possibly acting as gateways to other realities or revealing the vacuum's deepest secrets. Imagine the death of a massive star. After exhausting its nuclear fuel, its core collapses under its own gravity, compressing into a point of infinite density, a singularity where the known laws of physics break down. Surrounding this singularity is the event horizon, a boundary from which not even light can escape. This is a black hole, a cosmic abyss warping space-time around it so extremely that anything crossing its threshold is doomed to disappear. But the fascinating part is that even near a black hole, the quantum vacuum continues to manifest itself. In fact, the interaction between the vacuum and the extreme gravity of a black hole led to one of the most revolutionary predictions in modern physics: Hawking radiation. In 1974, Stephen Hawking proposed that black holes are not completely black. They emit a faint thermal radiation, as if they had a temperature. This radiation actually originates from the vacuum just outside the event horizon. How is this possible? Remember that the vacuum is full of virtual particle pairs that constantly appear and disappear. Near a black hole's event horizon, gravity is so intense that it can separate one of these particle pairs before they annihilate. One particle falls into the black hole, while its partner escapes into outer space. This escaping particle is what we observe as Hawking radiation. In effect, energy is borrowed from the black hole, causing it to slowly lose mass and eventually evaporate over vast stretches of time. This phenomenon is a stunning proof that the quantum vacuum not only exists, but also interacts profoundly with gravity at extreme scales. It demonstrates that even in the most inhospitable conditions in the universe, vacuum activity is relentless and its effects are tangible. Black holes, far from being simple devourers, become quantum windows where the dance between gravity and vacuum produces phenomena that defy our intuition. The implications are profound. Black holes are not holes in the absolute sense of emptiness. They are regions where the vacuum's energy density is affected in extreme ways. They could be considered points where the vacuum reaches maximum information density or where space-time is compressed to its quantum limit. Some theorists even speculate that black holes could be portals to other universes or regions of space-time, not as physical journeys, but as points of connection for vacuum fluctuations on a cosmic scale. Imagine that matter falling into a black hole is fundamentally reconfigured into the energy of the vacuum inside. This opens the possibility that information is not lost, but encoded in the quantum properties of the event horizon or in the vacuum itself, a central idea in the enigmatic black hole information paradox. Furthermore, the existence of Hawking radiation and the way the vacuum interacts with black hole gravity lead us to question the vacuum itself. In its most fundamental state, it possesses even more complex properties. If the vacuum is the matrix of everything and black holes represent the maximum collapse of matter, could these extreme phenomena be places where the vacuum reveals its true nature as the primordial foundation of reality? Black holes, simply by existing and interacting with the quantum vacuum, force us to expand the limits of our imagination and scientific understanding. They are the most powerful reminder that the universe is far stranger and more wondrous than our everyday perception allows. In their depths, in the dance with the vacuum, lie the secrets of creation and destruction, showing that even what seems like a point of no return is actually a site of intense quantum activity, a portal to a deeper understanding of existence. The overall entropy of the cosmos continues to rise, yet within this vast system, temporary islands of order can emerge. It is the inherent disorder of the vacuum itself, this constant stream of energy appearing and disappearing, that provides the dynamic backdrop upon which complexity can arise, develop, and evolve. The connection between vacuum and entropy leads us to a vision of the universe that is at once deeper and more paradoxical. It shows us that chaos at the most fundamental level is not an obstacle, but an essential condition for existence, evolution, and ultimately, life itself. The vacuum, with its unending bubbling of virtual particles, is not inert nothingness, but the beating heart of a constantly evolving cosmos. A place where chaos becomes the silent engine of creation and complexity. It reminds us that even in the apparent disorder of the cosmos, there is an underlying structure allowing the universe to continue, guided by the invisible pulse of nothingness itself. Chapter 8. Quantum information in the vacuum. Is our universe a hologram? We have delved into the depths of energy and the forces of the quantum vacuum, understanding that it is not emptiness, but an active engine of reality. Now prepare for one of the most mind-bending ideas of modern physics, one that challenges our very perception of what is real. What if the vacuum contained not only energy but also information? Could the vast, intricate reality we experience be a projection, a delicate hologram where every detail of the cosmos is encoded in the invisible fluctuations of this quantum sea? Since the beginning of the universe's expansion, the amount of information has grown exponentially. Every star, planet, molecule, and interaction represents data encoded in matter and energy. There is a fundamental place where this information seems to originate or be stored: the vacuum. The idea of a holographic universe arises from attempts to reconcile gravity with quantum mechanics, particularly in the context of black holes. As we have seen, black holes appear to devour information, a paradox conflicting with quantum laws that assert information can never be destroyed. To resolve this, physicists such as Gerard T. Hooft and Leonard Susskind proposed the holographic principle, the notion that all information contained within a volume of space can be encoded on a lower dimensional surface surrounding it. Imagine a three-dimensional hologram. All the information of the object is recorded on a two-dimensional plate. Similarly, all the information describing our universe could be encoded on a two-dimensional surface at the cosmic boundaries, or, more fundamentally, in the fluctuations of the quantum vacuum itself. This would mean that the virtual particles flitting through the vacuum are not merely bursts of energy, but carriers of information. Each appearance and disappearance of these particle pairs is not a random event, but a coding of the vast data shaping our universe. It is as if the vacuum were a screen of infinite pixels, flickering endlessly, each blink contributing to the overall image of reality. What we perceive as solid objects, three-dimensional space, and the flow of time may be projections of more fundamental two-dimensional interactions occurring at the level of the vacuum. It is as if we live inside a colossal quantum simulation with the source code inscribed on the surface of nothingness. This idea challenges intuition. Our daily experience tells us reality is solid and three-dimensional, yet quantum physics repeatedly shows that at its deepest level, the universe is far more malleable and astonishing than our senses suggest. If the universe is a hologram, then the vacuum is the matrix where all information is stored and processed, the digital canvas upon which reality is painted. The implications are staggering. If our reality is a projection, what does that mean for our existence? Are we ourselves information encoded in the vacuum? This invites us to reconsider the nature of consciousness, matter, and space-time. Perhaps consciousness is not merely a product of the brain, but a way in which the information of the vacuum organizes and experiences itself. The holographic universe hypothesis, driven by the informational nature of the quantum vacuum, opens a window to a cosmos where nothingness is the universal library, the archive that preserves every bit of existence. It challenges us to look beyond the surface of what our eyes perceive, recognizing reality as an ongoing dance of energy and information, whose complete script could be written in the invisible heart of the void. Once contemplated, this vision has the power to profoundly transform one's understanding of the universe. Chapter 9. Consciousness and the Vacuum. The mind as a cosmic mirror. We have explored the quantum vacuum as a vast ocean of energy and information, a possible architect of reality itself. Now comes the most intimate and profound question of our journey. Is there an intrinsic link between our consciousness and the quantum vacuum? Could our mind be not just a product of the brain, but a cosmic mirror interacting with, or even emerging from, the deepest fluctuations of nothingness? Since time immemorial, consciousness has been the ultimate enigma. That spark allowing us to perceive, think, feel, and be aware of our own existence. Traditional science has largely treated it as an emergent property of the brain's complexity, a network of neurons and biochemical interactions. Yet quantum physics invites us to look beyond this materialist perspective, suggesting that the substrate of reality is far subtler and more interconnected than we imagine. Here is where quantum consciousness theories come into play, proposing a deep interaction between the mind and the quantum world. If the vacuum is the foundation of reality, a field of potential and information, then it is conceivable that human consciousness, at its most fundamental level, is intertwined with this field. Some scientists and philosophers speculate that the mind is not merely a neural epiphenomenon, but that its processes could involve quantum phenomena occurring in the brain, such as superposition or entanglement. If these quantum processes are essential to consciousness, then our minds are intrinsically linked to the same quantum vacuum from which they arise. It is as if the brain were an antenna, tuned to the subtle vibrations of the field of energy and information that is the vacuum. Imagine consciousness as a sacred filter, a unique ability that allows us to collapse the infinite possibilities of the vacuum into the singular reality we experience. At the quantum level, particles exist in superposition, simultaneously occupying multiple states until observed. Could consciousness itself be the act of observation that interacts with the vacuum, selecting a specific reality from the vast field of potentials? This idea echoes ancient spiritual traditions that spoke of a universal mind, a cosmic consciousness of which all individual minds are a fragment. If the quantum vacuum is the reservoir of all energy and information in the universe, it could also serve as the substrate of a primordial form of consciousness that permeates existence. Our individual awareness would then be a reflection, a small ripple in this vast ocean of cosmic consciousness expressed through the intricate neural networks of our brains. Consider that vacuum fluctuations are not mere random noise. They are the universe's fundamental language, signals shaping matter and reality. If consciousness can attune to these signals, or even be one of them, our minds may be far more deeply connected to the cosmos than conventional science has suggested. This does not imply that consciousness creates reality from nothing, but that it actively participates in the manifestation and perception of existence. The implications are profound. If a link exists between consciousness and the vacuum, our minds are not isolated from the universe. We are an integral part of its fabric, and our subjective experiences may resonate at a quantum level with the entire cosmos. This invites us to see our own minds as microcosms of the universe, reflecting the complexity, potential, and mystery of the vacuum itself. This chapter challenges us to redefine what it means to be conscious, to recognize the mind not as a mere biological machine, but as a bridge to the universe's depths, a mirror reflecting the infinite possibilities embedded in the heart of the quantum vacuum. It is an invitation to an inner journey as vast and mysterious as the exploration of the outer cosmos. We have ventured to the frontiers of wonder, exploring the energetic and informational nature of the quantum vacuum, and even its possible connection to our own consciousness. Now, prepare for one of the most expansive and liberating ideas emerging from this profound understanding. The vacuum is not merely a sea of energy or a storehouse of information, but a field of unlimited potential where everything possible exists simultaneously until brought into manifestation. In everyday life, reality seems fixed with a linear past, present, and future. We assume things simply are or are not, yet at the quantum level, certainty dissolves. Particles do not exist in a defined state until observed or measured. Before that moment, they exist in a superposition of possibilities. Imagine a die spinning through the air until it lands, revealing one face. All faces were equally possible. The vacuum is that die spinning endlessly. This concept extends to the vacuum itself. If it teems with quantum fluctuations, with virtual particles appearing and vanishing, it is in a state of constant potentiality. The vacuum is not a blank canvas awaiting paint. It is a canvas that already contains every possible painting, every combination of colors and forms waiting to be selected. It is a vibrant field where all conceivable realities coexist as probabilities. Imagine the universe not as a book already written, but as an infinite library of books yet to be authored. The quantum vacuum is that library, containing the plot of every possible story, the outcome of every adventure, the birth of every star, and the collapse of every galaxy. Every event in the universe, every choice we make, every thought we have, could collapse one of these infinite possibilities into tangible reality. This does not mean our minds create existence from nothing. Rather, consciousness may serve as a focal point, a mechanism through which the vacuum's limitless potential manifests into experience. It is as if the vacuum offers a vast menu of possibilities, and our interaction, whether through scientific observation or conscious experience, selects a particular option. The implication of the vacuum as a field of infinite potential is staggering. Existence at its core is not a set of fixed facts, but a constant flow of possibilities being actualized. It is the true meaning of everything and nothing. Within its apparent emptiness, the vacuum holds the totality of what can be. This perspective transcends materialist views of existence. If the universe continuously emerges from a field of potential, then creativity is not merely human, it is a cosmic force. The universe itself is in perpetual creation, driven by the infinite possibilities residing in the heart of the quantum vacuum. Each moment is a new birth, a fresh realization of potential. Consider how this transforms our understanding of miracles or highly improbable events. If the vacuum contains all possibilities, what seems impossible in our current reality may simply be a possibility with a very low probability, but not absent from the field of potential. Ultimately, if the vacuum is universal potential itself, we are woven into this vast network of possibilities. Our being is connected to this boundless field, empowering us to see reality not as a fixed prison, but as an ever-evolving canvas with an infinite palette, residing at the very essence of nothingness. The vacuum is not only the origin of our universe, but the inexhaustible source of its ongoing evolution, the infinite realities yet to manifest. Chapter 11. The Future of the Quantum Vacuum. Technologies Beyond Imagination. We have navigated the astonishing realm of the quantum vacuum, uncovering its secrets as a sea of energy, a field of information, and a wellspring of unlimited potential. Now, allow us to venture to the frontier of what is possible and speculate about the future that awaits humanity. If we master the understanding, and perhaps even the manipulation of this immensely potent nothingness, what revolutionary technologies might emerge beyond the limits of our current imagination? Consider the history of science. Every major breakthrough, from harnessing electricity to unlocking nuclear energy, has opened doors to innovations that once seemed pure fantasy. Understanding the quantum vacuum could represent the next monumental leap, a revolution capable of redefining civilization itself and our relationship with the cosmos. One of the most thrilling and audacious applications would be the generation of limitless energy. If the vacuum truly is, as we have explored, a vast ocean of energy manifesting continually through virtual particles, then in principle, an inexhaustible power source permeates every cubic centimeter of space. Imagine a device capable of efficiently harvesting even a fraction of that energy, converting the ceaseless bubbling of the vacuum into usable electricity. Such technology could permanently resolve the global energy crisis, eliminating the need for fossil fuels or even nuclear power, ushering in an unprecedented era of energy abundance. Beyond energy, mastery over the quantum vacuum could revolutionize space travel. Vacuum fluctuations and their interaction with space-time underpin theoretical concepts such as exotic matter with negative pressure, potentially enabling warp drives or other forms of faster-than-light propulsion. These technologies could distort space-time around a spacecraft, drastically shortening distances and allowing interstellar journeys within human timescales. We would not be traversing space in the conventional sense, but bending space itself, powered by the energy of nothingness. Consider also quantum computing at its most extreme. If the vacuum is a vast repository of information, and if consciousness can interact with it, future technologies might allow us to access or process this information in ways that today seem purely science fiction. Computers might operate not on binary bits, but on qubits derived directly from the properties of the vacuum, opening computational capacities capable of solving problems currently deemed unsolvable. Quantum teleportation, already demonstrated on a tiny scale, could advance exponentially if we better understand how information entangles through the vacuum. Mastering the underlying connections provided by the vacuum could allow the instant transmission of information or even objects across vast distances, breaking the conventional barriers of space as we know it. And it does not stop there. If the vacuum is the field where all possibilities exist, could advanced manipulation of this field allow reality itself to be engineered at a fundamental level? This enters the realm of boldest speculation. If the reality we perceive is a manifestation of information in the vacuum, could we one day influence this manifestation at the quantum level to create new materials with impossible properties or even alter biological processes in ways we cannot yet conceive? Of course, these are glimpses of a distant future, fraught with immense scientific and ethical challenges. Yet history teaches that what today seems beyond imagination may tomorrow become the foundation of our reality. The quantum vacuum, once regarded as mere emptiness, emerges as the key to unlocking a new age of technological wonders, a testament to the fact that the greatest discoveries often lie hidden within what we least understand, and that nothingness might paradoxically be the source of everything. Chapter 12. The duality of the vacuum particle, an eternal dance. Having glimpsed the future possibilities of the quantum vacuum, we now return to its most enigmatic foundations, a property underlying all manifested reality, even in apparent nothingness, the wave-particle duality. How does this eternal dance between diffuse wave and discrete particle shape the formation of matter and the laws governing our universe, even from the depths of the vacuum itself? At the quantum level, things are not what they appear. On our macroscopic scale, we distinguish clearly between a wave, like ocean waves or sound waves, and a particle, like a ball or a grain of sand. Yet at the scale of the infinitesimal, this distinction dissolves. Fundamental entities such as electrons, photons, or even the vacuum's virtual particles are neither purely one nor the other. They exhibit an astonishing duality, behaving as waves or particles, depending on observation or interaction with their environment. Imagine a photon, a particle of light. Pass it through a double slit, and it behaves like a wave, producing an interference pattern on a screen, as if a series of overlapping waves. Observe which slit it passes through, and it behaves as a discrete particle, choosing only one path. This paradox lies at the heart of quantum mechanics and extends to the quantum vacuum itself. Fluctuations in the vacuum, the ceaseless bubbling of energy, can be seen as both a sea of vibrating potential waves and ephemeral particles. It is a cosmic ballet in which energy flows fluidly between diffuse and localized forms. This duality is crucial because it demonstrates that the vacuum is not static. It is a dynamic, vibrant field where the rules of existence rewrite themselves continuously. Vacuum energy waves ultimately give rise to particle manifestation. When vacuum energy collapses or condenses at a point, a particle emerges. When that particle dissolves back into the vacuum, it returns to its wave state. Imagine an ocean. Waves concentrate and break into droplets, ephemeral particles that dissolve back into the water. The vacuum is this primordial ocean, and particles are its fleeting droplets. Wave-particle duality in the vacuum means that matter and energy in our universe are not separate, immutable entities, but transient manifestations of a continuously flowing underlying field. This perspective profoundly affects our understanding of the cosmos, suggesting that even the space-time we perceive as three-dimensional may emerge from the interactions and vibrations of a more fundamental field, the vacuum. In its duality, the vacuum is the substrate from which particles, forces, and ultimately all observable structures arise. It is the primordial fabric where the line between physical and ethereal blurs. The constant transformation between wave and particle states maintains the universe in perpetual creation and dissolution. It is the heartbeat of existence, ensuring reality remains dynamic, ever-changing, and full of potential. The duality of the vacuum particle is not merely a quantum curiosity. It is a revelation that nothingness is the arena for the most fundamental dance of the cosmos, an eternal choreography shaping all that is and all that may be. Chapter 13. The vacuum as the foundation of reality, beyond matter. We have traversed the mysteries of quantum vacuum fluctuations, its interplay with consciousness, and the wave-particle duality. Now we take an even bolder leap to the question underlying all others. What if the vacuum is not mere space, not even just a sea of energy, but the ontological foundation of reality itself? What if this apparent nothingness is the primordial substance from which everything emerges, challenging our deeply ingrained materialist worldview? Since the dawn of philosophy, humanity has sought the universe's fundamental substance. For centuries, the prevailing answer was matter. We assume the universe is built of solid, tangible bricks, atoms, molecules, galaxies, even ourselves. Space between them was merely the arena in which these objects reside. But quantum physics dissolves this simplistic image. If the quantum vacuum is a field of ceaseless activity, with virtual particles appearing and vanishing, latent energy capable of manifesting as matter or radiation, then nothingness is not inert. It is the active matrix of existence, the canvas, the artist, and, in a sense, the painting itself. This leads to the profound idea that the vacuum might be the most fundamental basis of reality, the true substance from which everything else is a manifestation. Imagine matter, energy, even space and time as emergent patterns forming within the vast, complex network of the vacuum. The vacuum is a vast ocean, and what we call matter are the waves, the foam, the transient swirls appearing on its surface. The waves are real, the foam visible, but their essence is the underlying ocean itself. Similarly, the material universe could be understood as a densified manifestation, a condensation of the inherent fluctuations of the vacuum. This perspective echoes ancient Eastern philosophical traditions, which described emptiness not as mere absence, but as the source of all manifestation, a field brimming with potential. Modern science, through the study of the quantum vacuum, seems to be rediscovering these millennia-old intuitions, providing them with empirical support. The vacuum is not what it is not. It is what potentially can be everything. Consider the fundamental properties of particles, their mass, charge, and spin. These are not necessarily intrinsic attributes of an isolated particle, but qualities that emerge from its interaction with quantum vacuum fields, such as the famous Higgs field that gives particles mass. The vacuum is not merely the stage where particles move. It is an integral part of their identity and interactions. If the vacuum is the ultimate foundation, then reality is not a static collection of objects, but a dynamic flow, a constant interaction with an underlying field. Every atom in your body, every ray of light that reaches you, does not merely exist in the vacuum. It is in perpetual dialogue with it, emerging from its primordial source and returning to it at every instant. This perspective radically transforms our understanding of existence. We are no longer isolated islands of matter floating in an empty universe, but points of consciousness and energy, manifesting within a vast and omnipresent fundamental field. It connects us not only to the cosmos, but to the very essence of reality, revealing that we are intrinsically intertwined with the origin of everything. Understanding the vacuum as the foundation of reality invites humility and awe. It shows us that nothingness is, in fact, the beating heart of existence, a place where the distinction between being and non-being dissolves, revealing a cosmos infinitely more mysterious, interconnected, and full of potential than we had ever dared to imagine. Chapter 14. Quantum Fluctuations. The invisible heartbeat of the universe. We have explored the idea that the quantum vacuum is the foundation of reality, the primordial substrate from which everything emerges. Now, it is time to delve into the central mechanism driving this astonishing activity: quantum fluctuations. These are the true invisible heartbeat of the universe, tiny yet omnipresent seeds shaping the creation and evolution of the cosmos at every moment. Imagine the space around us, even the regions that appear most inert and empty. Our intuition tells us there is nothing there, but quantum mechanics reveals a much deeper dynamic truth. At the subatomic scale, the vacuum is never at absolute rest. It is in constant agitation, an unending dance of energy. These are the quantum fluctuations of the vacuum. Remember Heisenberg's uncertainty principle, which states that we cannot know certain complementary properties of particles with absolute precision. This uncertainty is not a limitation of our instruments. It is an inherent property of the universe itself. In terms of energy and time, it means that energy can fluctuate in the vacuum over extremely brief intervals. How does this manifest? Pairs of virtual particles and antiparticles spontaneously appear. An electron and a positron, for example, can emerge from nothing, exist for an unimaginably brief instant, perhaps 1/1,000,000,000 of a second, and then annihilate each other, returning their energy to the field from which they arose. It is as if the vacuum is constantly blinking with these fleeting births and deaths. Picture the vacuum as a vast, turbulent ocean. Quantum fluctuations are the waves and whirlpools that form and dissolve on its surface at every moment. Individually, they are ephemeral and impossible to observe directly, but their collective effect is immense and measurable. A clear example is the Casimir effect. The pressure exerted by these virtual waves produces an attractive force between nearby metal plates. The impact of these fluctuations goes far beyond that. They are essential for the stability of atoms. Clouds of virtual particles surrounding electrons, for instance, modify their energy and interactions with the atomic nucleus. Without these fluctuations, atoms would be different, and chemistry as we know it would not exist. In a very real sense, the heartbeat of the vacuum enables matter to exist and organize. Moreover, quantum vacuum fluctuations are considered the primordial seeds from which galaxies and the large-scale structures of the universe formed. In the earliest moments of the Big Bang, during the cosmic inflation phase, these tiny irregularities were stretched to cosmic scales, becoming the gravitational seeds that eventually formed galaxies, clusters, and the vast cosmic web we observe today. The universe, on its largest scale, is a colossal echo of these minuscule initial fluctuations. Quantum fluctuations are not merely a technical concept, they are a revelation about the dynamic nature of reality. They show us that the cosmos is not an inert backdrop where things simply exist, but a field of constant creation where energy manifests and dissolves, giving rise to matter. The forces and structures we know are the invisible heartbeat of the universe, a constant reminder that nothingness is teeming with potential and activity. This understanding compels us to view the cosmos not as a static machine, but as a living organism, always in flux, continually creating and recreating itself from its deepest foundations. Quantum fluctuations are the breath of the universe, the most elemental expression of its inexhaustible vitality. Chapter 15. The Vacuum and Quantum Teleportation. Breaking the Barriers of Space. We have understood that quantum fluctuations are the vital heartbeat of the universe, the seeds of all creation. Now let us explore one of the most astonishing consequences of quantum physics: quantum teleportation. A phenomenon that seems like science fiction but is a reality in laboratories worldwide. How does the quantum vacuum influence this marvel? By breaking the barriers of space and opening the door to a cosmic connectivity that defies our most deeply ingrained logic. When we think of teleportation, our minds conjure images from television series where people or objects disappear from one place and instantly reappear in another. Quantum teleportation does not work exactly like that. It does not transport matter. It transmits the quantum state of a particle from one point to another without the particle itself traveling physically. It is as if we send the complete barcode of a particle to another location, where a new particle is printed with that code, replicating its exact properties. The core of quantum teleportation lies in quantum entanglement, a phenomenon we will explore in greater detail later. But it is crucial to understand the role of the vacuum. It is not empty. It is filled with virtual particles and an immense network of fields that interconnect the entire universe. It is an invisible sea of information and potential, and teleportation is one way to surf its waves. Imagine you want to teleport the state of a photon. You cannot simply scan it and reconstruct it because the very act of measurement would destroy its delicate quantum state. This is where the magic of entanglement comes into play. Two auxiliary particles, A and B, are entangled in such a way that their states are intrinsically linked, regardless of the distance between them. Then, when the particle you wish to teleport, P, interacts with A, the information about P's state is instantly encoded into B through its entanglement with A. Particle B, even if it is kilometers away, assumes the state of P. And all of this is made possible by the quantum vacuum, the fabric that allows these persistent connections to exist and enables quantum information to be transmitted coherently across space. The fluctuations of the vacuum, far from being mere noise, are the silent language that allows instant conversation between entangled particles. They are the substrate that ensures that when a particle is read in one place, its partner is written with the same state elsewhere, without anything visible traveling between them. Imagine the vacuum as a gigantic cosmic neural network, a sort of quantum internet. When two particles are entangled, it is as if they share a direct connection, an informational tunnel linking them through this vacuum network. Quantum teleportation is the manifestation of how information can leap from one node to another in this fundamental network, using the vacuum as an invisible conduit. This ability to transmit quantum states across distance has revolutionary implications. It is currently used for secure quantum communication, where information cannot be intercepted without being destroyed, laying the groundwork for an unbreakable quantum internet. In the long term, a deeper understanding of how the vacuum facilitates these connections could lead to unimaginable advances, perhaps even revealing how information organizes itself in the universe on much larger scales. Quantum teleportation is a striking reminder that space, as we perceive it, is far more flexible and malleable than we ever imagined. Nothingness is not an obstacle to connection. It is the very catalyst for the deepest, most mysterious links in the universe. It shows us that barriers we once thought insurmountable may be mere illusions, and that the quantum vacuum is the key to unlocking a cosmos where information flows freely, breaking the limits of what we considered possible. It is a window into a universe where connectivity is fundamental and where what once seemed like science fiction is a stunning manifestation of the laws of reality. Chapter 16: The Vacuum and Quantum Entanglement, the Invisible Cosmic Connection. We have glimpsed how the quantum vacuum enables marvels like teleportation, acting as a medium for information transmission. Now let us delve into the heart of this miracle. Quantum entanglement may be facilitated by the vacuum, with its ceaseless bubbling of energy and vast informational field, forming the underlying fabric that allows instantaneous connections between particles, revealing a fundamental unity in the universe that goes beyond our everyday understanding. Imagine two coins. If you flip one and it lands heads, the other can land heads or tails independently. There is no connection between them. But in the quantum realm, things are radically different. Quantum entanglement is a phenomenon in which two or more particles are formed or interact in such a way that their fates are intrinsically linked, no matter the distance between them. If you measure the property of one, you instantly know the property of the other, even if they are light years apart. Albert Einstein, perplexed by this, called it spooky action at a distance. How is this possible? No signal travels from one particle to another. There is no invisible cable or physical communication crossing space. The connection is instantaneous, defying the speed of light in classical intuition. Here is where the quantum vacuum comes into play, not as empty space, but as the fundamental mediator of this astonishing relationship. Imagine the vacuum as a vast ocean of potential and invisible connections. When two particles become entangled, it is not that a new connection is created, but that their states synchronize in a way that resonates with the fundamental structure of this quantum ocean. It is as if the vacuum were an omnipresent cosmic neural network, and the entangled particles are nodes in that network, activating simultaneously. They do not need to send signals because they are already part of an underlying unity connecting them through the depths of the vacuum. The quantum fluctuations of the vacuum, that ceaseless dance of energy and virtual particles, are not just noise. They are the medium through which information flows at the most fundamental level. It is within this substrate that the entangled connection is recorded. When we measure an entangled particle, we are, in a sense, interacting with a localized manifestation of information that already exists in the vacuum field. That interaction instantly defines the state of its distant partner through the pre-existing connection in the fabric of the cosmos. Consider the profound implication. If the vacuum is the matrix that enables entanglement, then the entire universe could be fundamentally interconnected. Every particle, every atom, every galaxy could be linked on a level beyond what we can see or touch. Our perception of things as separate and discrete would be an illusion on the macroscopic scale. At the level of the vacuum, everything is unified. Everything is part of an interconnected cosmic network. This vision leads us to reevaluate our own existence. If we are collections of particles, and those particles can be entangled with others throughout the universe via the vacuum, what does that mean for our individuality? We may, in a profound sense, be localized manifestations of a vast unified quantum field, and our minds, as explored in Chapter 9, could be tuned to that cosmic resonance. Quantum entanglement, facilitated and sustained by the vacuum, is one of the most powerful proofs that reality is far stranger and more wonderful than our senses suggest. It shows us that connections do not always require distance to traverse or a visible physical medium. The deepest connections in the universe are invisible, ethereal, and embedded in the very heart of nothingness. The vacuum is not merely the backdrop of existence. It is the warp and weft weaving the immense web of relationships that constitute our universe, revealing a fundamental unity that invites constant awe. Chapter 17. The temperature of the vacuum, a cosmic cold full of life. We have navigated the mysteries of the quantum vacuum, understanding its role in entanglement and cosmic connectivity. Now, let us explore one of its most paradoxical properties. Despite its apparent coldness and emptiness, the quantum vacuum possesses an intrinsic temperature. What implications does this cosmic cold have for the stability of the universe? Surprisingly, it may be essential for the possibility of life in the most inhospitable corners of the cosmos. When we think of the vacuum of space, we imagine an extreme cold close to absolute zero, where matter and energy are scarce. And to a large extent, this is true for interstellar and intergalactic space. Yet, at a more fundamental level, the quantum vacuum is not a place of thermal immobility. As we have seen, it is in a state of constant agitation, a hotbed of virtual particles appearing and disappearing. This inherently energetic activity gives it a form of temperature. The concept of a vacuum temperature arises from various perspectives in quantum field theory. One of the most famous is Unruh radiation. The Unruh effect predicts that an observer accelerating through the vacuum will perceive a thermal bath of particles, as if the vacuum were hot. This is profoundly strange because, for an inertial observer not accelerating, the vacuum appears cold and empty. It reminds us that the very definition of particle and vacuum depends on the observer's state of motion. Beyond acceleration, the vacuum itself has a background temperature related to its inherent fluctuations. While it is not a temperature we could measure with an ordinary thermometer, its effects manifest in the way quantum fields interact and in the energy the vacuum can harbor. This vacuum energy is what some postulate as dark energy, the ghostly pressure driving the accelerated expansion of the universe. Consider the cosmic microwave background, CMB, the fossil radiation of the Big Bang, the residual heat of the early universe. Today, it has a temperature of approximately 2.7 Kelvin, nearly minus 270.5 degrees Celsius, an icy cold. Yet even in this extreme cold, the vacuum still contains its own intrinsic energy, which does not cool in the same way as matter or radiation. The implication that the vacuum possesses a temperature, however subtle, is crucial for the universe's stability. If the vacuum were truly nothing in the absolute sense, with no energy or fluctuation, the universe could not exist as we know it. The vacuum's intrinsic temperature is a manifestation of its zero-point energy, the minimal energy a quantum system cannot lose, even in its ground state. It is like the constant hum of a motor that never shuts off, even when the car is stationary. This energy is not an anomaly, but an integral part of the universe's physics. It is this intrinsic vitality of the vacuum that contributes to the conditions enabling the formation of stars, galaxies, and ultimately life. In a paradoxical sense, the apparent cold and stillness of the cosmic vacuum is brimming with latent energy, the foundation of all existence. Consider the delicate balance that allows the universe to be habitable. If the energy of the vacuum were slightly different, or if its intrinsic temperature were not finely tuned, the universe could have collapsed in on itself or expanded so rapidly that galaxies, stars, and planets would never have formed. The mere existence of this inherent vacuum temperature shows us that nothingness is not an inert space, but a dynamic and perfectly balanced fabric that sustains the structure and evolution of the cosmos. Even in the most remote and coldest regions of the universe, where everything seems still and empty, there is a constant dance of quantum activity. This vacuum temperature is not just an abstract curiosity. It is a window into the hidden vitality of nothingness, a reminder that even in the deepest darkness, a fundamental energy pulses, shaping all reality and perhaps subtly connecting life to this cosmic chill. We have explored the mysteries of this vacuum temperature, uncovering its hidden energy. Now, I invite you to expand our perception of reality by exploring one of the most intriguing ideas in theoretical physics. What if the vacuum not only harbors energy and information, but also additional dimensions beyond the three we perceive? The quantum vacuum could be the gateway to a multi-dimensional universe, vast and complex, where the laws of physics we know are only a partial reflection of something far greater. Our everyday experience places us in three spatial dimensions: up, down, left, right, forward, back, plus time, forming a four-dimensional space-time. However, for decades, physicists have speculated about extra dimensions rolled up or compactified on scales so tiny that we cannot detect them directly. Theories like string theory and M theory suggest that to unify all the forces of nature, including gravity and quantum mechanics, the universe may require 10, 11, or even more dimensions. If these dimensions exist, where are they? And crucially, how do they relate to the quantum vacuum? This is where the connection becomes fascinating. The vacuum may not be just the space we know, but the stage where these hidden dimensions unfold. Imagine that each point in our three-dimensional space is actually a tiny universe of additional dimensions, invisible to our eyes. The vacuum would then be the manifestation of these compactified dimensions, brimming with vibrations and fluctuations. Think of a garden hose from a distance. It seems like a simple line, but up close, you see its circumference, a hidden extra dimension. Similarly, extra dimensions might be so tightly folded, perhaps in complex shapes known as manifolds, that the particles and forces we experience remain confined to our three-dimensional reality. Yet the virtual particles of the vacuum, inherently quantum and minuscule, could move through these dimensions, appearing and disappearing, exploring realms beyond our reach. The vacuum thus becomes a cosmic explorer with access to the hidden folds of multidimensional reality. This interaction could explain phenomena like the relative weakness of gravity. If gravity can leak into extra dimensions while other forces remain confined, its effect in our three-dimensional universe would be diluted. The vacuum energy would not only generate known particles, but also mediate interactions across these hidden dimensions. Even what we perceive as dark energy could be a projection of energy residing in these additional spaces, hinting at a universe far more intricate and offering a path toward unifying the fundamental laws of physics if we understand the full geometry of these dimensions. The idea of hidden dimensions invites us to imagine a cosmos where nothingness is astonishingly complex and rich, where the layers of reality far exceed what our senses can perceive. The vacuum becomes the key to understanding a truly multi-dimensional existence, an infinite mystery waiting to be explored. We have lifted the veils of reality that the vacuum may conceal, and now we can reflect on an even deeper idea. Could the quantum vacuum be the foundation of a collective consciousness, a universal network of information connecting not just minds, but all of existence? Perhaps we are part of a greater cosmic intelligence, a reflection of the vitality inherent in the vacuum itself. The concept of a universal consciousness has been proposed by philosophers and mystics for millennia, but what is new is that quantum physics provides a framework for exploring it scientifically. If the vacuum is an ocean of energy and entangled information, it is not a passive container, but an active fabric connecting every corner of the cosmos. Every fluctuation, every virtual particle, could be a fragment of information in a vast cosmic network. Our individual consciousness could be a point of access to this network. Perhaps our brains function like antennas, receiving and processing information beyond mere neural activity, resonating with a universal mind that permeates existence. Quantum entanglement offers a poetic parallel. Particles separated by vast distances can share states instantaneously, suggesting that connection can exist beyond what is visible. This implies that intelligence and information might be inherent properties of the universe itself, encoded in the structure of the vacuum. In this sense, the universe may not be a blind machine, but a living system where the vacuum serves as the matrix of consciousness. Our existence would then be evidence that nothingness can generate not only matter and energy, but also the capacity for experience and understanding. While we are still far from proving these ideas, exploring the vacuum as a substrate for collective consciousness invites us to reconsider interconnection and individuality. Every thought and emotion could resonate through the cosmic fabric, reminding us to live with humility and wonder. At the end of this journey, we have traversed the secrets of the quantum vacuum, from its vital fluctuations to its role as a possible origin of the universe, its influence on cosmic expansion, and its connection to black holes and quantum entanglement. We have discovered that the vacuum is not empty but pulses as the fundamental heart of reality. We have seen the Casimir effect, marveled at virtual particles, explored dark energy, and the vacuum's role as the universe's primal spark. We have reflected on how it could be the foundation of hidden dimensions and even a universal consciousness, and how it could inspire unimaginable future technologies, from limitless energy to interstellar travel. The vacuum, once a symbol of absence, now reveals itself as the inexhaustible source of everything, the beginning and the end, matter and consciousness, science and mysticism. Understanding this cosmic fabric transforms our view of the universe and ourselves. Every question we've asked opens the door to new wonders. The exploration continues and the mystery of the cosmos awaits, inviting us to keep uncovering the secrets of reality and the infinite adventure of understanding.